SkyWatch is a space technology company that is bringing intelligence from space,
which tightly integrates the world's satellite operators, space agencies, and ground stations.
Trusted intelligence delivered in near real time when decisions matter most.
So at Esri, the idea is that imaging and remote sensing can really evolve and expand GIS workflows.
I am really excited to be here and having this conversation about an area that Space Capital believes is one of the greatest opportunities in the space economy today. First, before we get into it, I think that there's a couple of terms that I think we're going to use a lot in this conversation that are worth defining, right? So, geospatial intelligence. If you're involved with Space Capital at all, you hear us talk about this a lot. It is the collection and analysis and visualization of location-based intelligence in order to produce actionable insights. So basically, it enables you to answer questions like, what is happening where, right? So GIS, Geospatial Information System, is the indispensable toolkit and infrastructure for geospatial intelligence, okay? So geospatial intelligence and GIS is the toolkit that enables it. Earth observation. I think a lot of people in the audience even might conflate these two things, but it is separate. Earth observation is the collection and analysis of information about the Earth's physical, chemical, and biological systems. Typically, this is through satellites, drones, UAVs, that sort of thing, right? So this is the data supply, and it's also all of this stuff that's up above us is also sometimes complemented with ground sensors and some other things. So two distinct things, very important. So they are both already today multi-billion-dollar markets, and they're growing steadily. Most forecasts put these showing steady linear growth, and they base this on advancements in satellite technology and rising demand for these location and geospatial analytics. But there are structural changes that are underway that are bringing the worlds of Earth observation and geospatial intelligence together. And these structural changes are going to significantly accelerate the market growth. And so that's what we're here to discuss today. And I'm joined by an incredible panel of people who can help us make sense of all this and see where we're going. So I think hopefully you've gotten a sense from the conversations today, starting with GPS and Trimble, that what we're trying to do is not just look at the space infrastructure and the cool hardware and satellites that are up there, but it's how this infrastructure is being used and the applications that are being built on top of this, and focusing on the market demand. So why are we actually even building them in the first place, right? So we have Beau here, who is with Esri, as you saw. So Esri is the leader in location intelligence. They have over 680,000 customer organizations, which represents millions of users, right? So this is the guy to be able to help us understand how people are actually using geospatial data. And so I'd like to start with that and just sort of get a sense for who's using this, and who are they?
Yeah, thanks. So GIS, for over 50 years, Esri has been involved in people understanding their location better, and that is GIS. And thanks for that definition, because not a lot of people still understand what it is. But it's really about understanding your location. And forever, people have done that using maps. And on those maps, they've just put information on those maps. And I think what we've seen over the last 5 to 10 years is the amount of information that people want to bring to those maps and the types of information and the pace at which they want to update those maps increase. And that has naturally led to people wanting to bring in Earth observation data into their maps. It's always been there from government sources, and a lot of the times it was used as a source to create the layers that were put on those maps that allowed people to understand their location. But it was really in the realm of the local government, the national government, or specialists who created those intelligence products. Increasingly now, people are like, I need to create my own. I need to create it, I need to know it now. And what's also been driving it is that a lot of industries are starting to understand the value of location in their systems. And that was not necessarily the case, say, 5 years ago. People are starting to see that if they bring in location into their business systems, into their, their ERPs, their SAPs, if they bring that in, they're going to get a business advantage. And the way they do that is by having data that is up to date, refreshed, that is increasingly powered by AI-driven insights. And that all lands on the map, and at Esri, we deliver that. So we're seeing just this demand happen for people wanting more and more data at a more rapid pace.
And the customer base too is, I mean, I mentioned a lot of organizations, but these are Fortune 100 companies.
Yes.
You have like almost all of them are customers and are using your tools.
Yeah, we are. Yeah, definitely. And so it's all up and down the tiering, as we call it. I mean, there are Fortune 100s. There are 1,000 resident local governments. Mm-hmm. Everybody sees the value, but more and more it is that larger company that's saying, I get an advantage by using location.
And can you give us a representative example of an Esri customer that, maybe one that was here earlier today?
You mean Trimble?
No, somebody, yeah, somebody. So like to give somebody an example of how location intelligence is important to their business.
Yeah, I mean, really, if you look at, say, precision ag, or you look at oil and gas, or you look at almost any vertical, yeah. They're going to derive intelligence out of, or they're going to drive advantage over location intelligence by understanding more about what's important in their business. So let's take an oil and gas company, and let's take somebody who wants to monitor their operation of their fields. It's more, you can't just know where the field is. You have to know what's going on in the field, and not what's going on in the field last week, what's going on yesterday. And so that means more information, more Earth observation data, whether or not that is just a picture of the field that you can derive intelligence from, or the greenhouse gas emissions from it, or the fire risk to it. So the last panel was very, very relevant. I mean, that is all information that is about a location that needs to be delivered downstream. Yeah. And so it has to be, it has to be captured, it has to be put in its location's context. Any further analysis of that data needs to happen, and then it needs to go out and be delivered. And that's all what a location system does.
So what percentage of the customer base would you say is using Earth observation today, and has that changed over the last few years?
Well, so it's an interesting question, because I'd say 100% of our customer base is using some form of Earth observation data, and I say that because almost 100% of our users use a satellite base map. Yep. To provide location. A satellite base map is the picture. It's an overhead picture, typically that comes from Maxar, that has very high resolution. It was taken at a point in time. Now, as we get down, who's using a more recent base map? Who's then using very specific Earth observation data to derive intelligence? It starts to go down in percentage, but that's our opportunity space. That's where we're seeing customers saying, what if I bring in more up-to-date electro-optical data, which provides the picture, or I bring in the data from the emissive regions, which is methane sat and what fire sat's doing. What if I bring in that data? Can I get more information and more up-to-date information? So those percentages are a lot lower, but we see that as the opportunity space, because we go out to those customers and we talk about the value of bringing that Earth observation content in and how it can increase their business value.
Nice. Okay, so I want to go to you next, James. Yep. So SkyWatch launched the first API in the world for geospatial data back in 2016. So this is somebody who knows quite a bit about how difficult the acquisition process is, how difficult it is to get your hands on timely, specific to your use case, Earth observation, remote sensing data. So we'd just really like to start with, can you walk us through what are the challenges in accessing that, and what are, how is SkyWatch providing a solution to that?
Yeah, so my job is to figure out how your 10 million users can access your data seamlessly, and not through the traditional base map, but through up-to-date products. How do we tap into those daily use cases? GPS is extremely relevant. When we started SkyWatch, we looked at that market and we tried to understand, why is that market 20 times bigger than the imaging industry? And why is it growing more rapidly, and why does it support trillions of dollars of products and services in a way that imaging just isn't doing? And from our perspective, we landed on 3 core attributes that the technology had. It was standardized, it was accessible, and it was affordable. And we looked at Earth observation, and it appeared to have the inverse of all those attributes. It was fragmented, it was inaccessible, and it was quite unaffordable to most parties outside of national government. And so we saw it as our mission to solve for those character attributes. And if we could do that, we could enable growth in the market that resembled what we've seen in GPS. More accessibility, more standardization, more affordability. And so when we think about standardization, when we started the company, there were really 3 imaging companies that mattered, right? This is early Falcon 9 years. Now you move into a more mature Falcon 9 market, and we have relationships with 30 operators today, so 10x in less than a decade. And then you look forward into a Starship world, and you'll have 300 operators. And the question we really want to solve is, how can we enable any single human on the planet to easily access and tap into that infrastructure? Those probably thousands of assets owned by 300 different entities, right? You need an abstraction layer. You need somebody who's going to come in and pull all that together and enable people to easily, with a simple request, not needing to know anything about that infrastructure, but they can leverage it. When you look at the affordability piece for us, that was quite simply really about automation. So, when we started, there was a lot of, and you'll remember these days quite well, there was a lot of manual processing. I don't even know if there was really any automated processing 10 years ago, very little of it. Orders were primarily done via PDF. A lot of our early API calls in 2016 and 2017, we converted into fax calls so that we can get an order into the operator desk with whoever we were working with at the time. It's quite, talk about doing things that don't scale, right? And it's really for us about automation. How can we make that node in orbit as accessible to anybody here on the planet as any other IP address on the planet? How can we really abstract the complexity of getting the order that you have up to that spacecraft and then getting the data back down to your API endpoint inside of your application in a way that feels magical? And so that's how we think about affordability. And then on the accessibility part, I think what's really different about our approach is that we fundamentally believe that users should not go searching for their data, but rather we should show up in the workflows and in the applications that you use every single day. So with Content Store, which we built with Esri, that's really around us saying, hey, so use case, let's say you're, the one I like to use is you're an analyst, or you maybe work on the geospatial team inside of a mid-sized municipality, say 300, 400,000 people. You're investing, maybe tens, if not hundreds of millions of dollars into a light rail transit project. You open up your base map inside of ArcGIS. You look at the image, and you know that your city doesn't look like that anymore. It's in the middle of a construction project. And so right now, that is where the adoption of Earth observation stops for about 90% of use cases. That person doesn't know where to get the data, how to get it, and even if they were, how to import it, process it, and bring it into ArcGIS. And working with Esri, the goal now is that analyst or that member of the geospatial team looks at that base map, they upload the shapefile that represents their light rail transit project, and they simply, right there on the spot, are able to say, hey, can you just monitor this for me once a week going forward? The order hits our back end, we send it up to our partners for capture, and then automatic delivery. And so that person went from problem aware to having a solution in the course of minutes. And that's just never been approachable or even possible in Earth observation. And for us, we fundamentally believe by merging the entire value chain together and really bringing data at the fingertips of where users are already doing their work, that's going to enable massive growth and unlock a lot of, it's really going to accelerate adoption and thus accelerate the economic impact that this data is having.
You cannot overstate, I think, the importance of what SkyWatch is doing, and they have been quietly building this thing for the last 10 plus years. And they are bringing the supply, the space infrastructure, to the demand, the user's customer base, right? And if you listen to what, like kind of reading between the lines of what James was saying, success for SkyWatch is that it's happened so seamlessly that you don't even know that they're there. Like all of these transactions are happening. And I think this is a fascinating sort of way to think about things, because this is kind of the power of the success of GPS, is that the complexity has been abstracted away to a degree in which it's happening without you even noticing it. This has been a theme throughout the talk today, and Rob was talking about it earlier, talking about how you have interacted with Trimble many times throughout the day today just getting here, right? But that's the beauty of it, is that it's all happening seamlessly, and you're getting access to the supply of data, and it's connecting it to the actual demand side of the equation. And that is really where the magic happens, I think. This partnership that you just announced with Esri and providing the Earth observation data to the Content Store, this is game-changing stuff. This happened a couple of months ago at Esri's big Fed GIS conference, and this is going to, this is the moment in which, back in GPS time when, I don't know, the iPhone 3G moment, right? When suddenly, you started to get it on devices that you were already using, that you wanted to use, and now it had this great capability that was also built in. That's where we're at right now. So this is going to be fun to look back on. You might not notice it right now, but you will. I want to then go to Will and talk to Maxar about the sensors. So Maxar has long been the leading provider of high-resolution Earth observation data to the United States government. Roughly 90% of foundational geoinformation used by U.S. national security missions comes from Maxar, right? So, but the U.S. government and the intelligence community are very sophisticated customers. They have whole teams that do data acquisition, structuring data, analyzing all that data, right? That's a very different sale. So as data becomes more accessible from Esri and SkyWatch, it's being used by a completely new type of user who doesn't really care about learning how to use it all and hiring whole teams to do this, right? So, how, the question for you, I guess, is, how is Maxar meeting the customer where they are, given that you're a data provider?
Yeah, so certainly one of these is our partnership with SkyWatch, as James alluded to. Partnership has been critical to providing our data, but also in imagery to different markets and users. But it also enables us to get additional solutions to the market. So we want to, in order to meet the customer closer to where we're at or where they're at, we are looking at value-added solutions. Number of recent examples. You may have seen we recently launched a GPS-denied navigational product built on our 3D base map, and so that's taking our raw imagery and converting a new tool and solution for the market. Similarly, we have a site monitoring capability now, and there's and we have quite a few partners involved to bring that to fruition. So as part of that solution, we leverage multiple constellations. We orchestrate those constellations to take the right picture at the right time of a location, whether that's for a military purpose or for an oil and gas customer that wants to monitor a specific site. And then we detect what are the objects in that site and what's the patterns that those objects are taking over time. I think, Maxar, we're very proud of many of the things we do, and we try to focus on what we're good at. But we also believe we're going to have to partner with many of the other solution providers that are out there, which is one of the amazing things about the market right now, is this proliferation of other solutions and capabilities. Bringing those together is going to enable us to serve our, maybe less sophisticated or users that just want the answer. They don't want to, torture pixels and integrate all the data. They want the answer. So.
And can we double click on that too? Because you've got a satellite with a particular type of sensor, and that sensor will give you answers to certain types of questions, right? But people have more generalized business questions, right, that aren't really tailored to the sensor type, right? And so they're thinking about this from a business perspective, right, which might require data from different sensor types in order to answer that question, right? So Maxar data is fantastic, high resolution, high quality, but then you're also, you've gotten involved with Umbra, for example, right, to bring in synthetic aperture radar data to complement your data set, and you're thinking about it from, operating, like we're going into a world of virtual constellations of different types of, different satellites made by different people that are, coming together to help provide solutions. So how is it, Maxar, you build your own satellites, you've got your own data set, but you're not just pushing your own data because that's not meeting the customer where they are. Like, how are you thinking about these virtual constellations and bringing, merging your data set with other different data types?
Yeah, so I think one of the things that's, I think, really important about our data, and I'll get to the question, but is the level of accuracy in that data. We have years of imagery and these very sophisticated satellites that have enabled us to get to an incredible accuracy, which enables better mapping products, better navigational products, and so on. It also enables us to georegister, to overlay other imagery accurately, and people know exactly what they're looking at. And so I think leveraging that strength to bring together, again, partners, constellation partners, and then present information to a customer in a way that they know exactly what they're looking at and can sort of flip through. If it's cloudy, I can flip and look at a SAR image, or if I need something that's very recent, I can perhaps look at a satellogic image, whatever the case. So I think that's a key piece of being able to integrate all of these different providers together. I think also the ability to orchestrate constellations. Obviously, we orchestrate our own constellations, so we choose the optimal time, the optimal sensor to look at to solve a problem. And I think we can take that knowledge and bring it to other constellations and sort of get the customer, so the customer doesn't have to do that, and get them closer to the answer versus sorting through a variety of options. And then obviously there's this getting the imagery and making it, I think, quite easy to order and access and distribute. And I think that's where James comes into play with SkyWatch. So.
When we talk about the quality of data, most people, I would assume, immediately go to the resolution, like how many centimeters, like how accurate am I, can I see a license plate, like that sort of thing. But you skipped over that and you actually went immediately to the accuracy of it, which is actually probably one of the most underappreciated and most important pieces, is like, is this image that you've got, like, is this data where it's supposed to be? Because if it's location data in the wrong place, it's not very good, is it, right? So like that's a super important piece of what's going on here. And I think I kind of want to open up this part to the whole panel, because I know, James, you've focused on this a lot as well, like, because you're talking about virtual, hybrid constellation. You are aggregating data from a bunch of different providers, structuring it, and making it accessible through an API. Like, how do you, like, that is a heavy lift, right? And so I want to kind of open that up to you guys, but also talk a little bit about like the importance of accuracy. Like, why are you spending so much time and resource to make sure that it's accurate? Because if you use that for current use cases and where we're going in the future, like with autonomous systems, it's super important.
I think accuracy is actually one of the largest, if not the largest, inhibitor to mass adoption. And that's because we can only do mass adoption if we can figure out autonomous distribution. And when we started in Earth observation, again, you'll remember these days, you would, when you bought an image, you would put it on Google Maps or some sort of satellite base map, and you would reference it to make sure it was spatially accurate. And 99 times out of 100, it wasn't. And you would realign it, and then you would readjust the pixel values, the lat-long pixel values, right? And one of the biggest challenges we've had in moving to autonomy and scaling up and making sure that we can distribute imagery out to the market without having humans check it is spatial accuracy, right? And especially as we start to think about how do we feed imagery into autonomous systems, right? So I would say over the last 10 years, the popular use case in precision ag was to feed imagery into a farm management information solution that someone would then view, but then still go run their tractor or their combine, right? And in the future, you'll feed those pixel values directly into autonomous farm equipment, right? And so you won't have the human in the loop there that's verifying the accuracy of that data. And to the point, if the pixel values are wrong, if the spatial accuracy is incorrect, then you're going to have a completely incorrect distribution of fertilizer, herbicide, whatever, right? Like the whole system is messed up. And that autonomous system or that capability is what we want to enable across many different industries and verticals, mining, energy. Think about in the drone domain, again, where you want to have your 3D base maps that you now have sitting on the edge, they need to be spatially accurate, or you're going to have some major problems. And so I think solving for spatial accuracy is one of the most important things we need to do to be able to scale up our entire infrastructure and enable mass adoption.
So, I mean, I'm just imagining, putting tracing paper on top and
Exactly.
doing it by hand, because this is the people who are really motivated in the beginning to use this data would jump through those hoops, right?
Yep.
That is no longer the case, and in order to open up the market, we need to do several things, right? And we need to make it abstract away the complexity and make it much easier. Where do you all think that we are on the adoption curve, and where do you think things are? Where do you see things going in the next few years?
We're getting close, but we still have a long way to go. I mean, the data has to be accurate, as you say. There has to be table stakes. We've also got to build workflows that take the technician out of the loop, because a lot of the uses of these data now still require somebody in the loop, and that's a skilled human, and that reduces the likelihood of scalability. So we've got to get that human out of the loop by driving accuracy, by driving these workflows to the point where they don't require a check, that there is confidence in the accuracy, there's confidence in the derivative products that are coming down, so that these derivative products can flow into these systems that James was talking about, like the precision agricultural system or the agricultural engineering construction system, where a drone is flying and building a digital twin of a construction site and comparing that to the as designed. So driving those efficiencies by, say, looking at the as built versus the as designed. You can't do that unless there's accuracy, there is a confidence in that geospatial product. So some of these areas are really getting there. AI-driven workflows are assisting in this. They're not 100% there, but they're getting better every month, it seems like. And we're also starting to get the temporal resolution that is being required for users to monitor. Temporal data used to be, first of all, it was prohibitive to get data on any type of temporal cadence, daily or weekly. Then Planet introduced us to daily revisit, but they had a constellation that was better for change monitoring, not necessarily precision object detection for their Planet scope. But now Maxar's got amazing capabilities coming down the pike very soon, if not today. So everything's lining up. We're getting there. Yep.
Okay. You guys have mentioned it a couple of times already, but the intersection of geospatial intelligence and AI is a key area of focus for us at Space Capital, where we're seeing a lot of innovation. And I mean, as we said many times throughout the day today, it is the only way to derive useful insights from these massive data sets that we're talking about is by running it through an AI system, right? So we are very bullish on this intersection and everything that's happening in GeoAI. I just want to get your take on, and we're actually actively deploying in this. Like we have in Fund 3, I think we've got several investments that we're making in this space. So how is AI impacting what you all do? That's for anybody.
Okay, I'll go first.
Yeah.
So a couple thoughts on AI as it relates to imagery. I guess the first is actually going back to the quality question of the raw pixels. Just like you can see better what's in an image with very high resolution, very high quality imagery, the same is true for AI. AI models work better on really good imagery. And they also enable some insights that can be carried over if you're looking at the same place. They allow you to extrapolate some of the learnings into a perhaps lower resolution image that's taken at a different time of day. I think, so that has to be a basis for AI that works, that has a high F1 score and detects the things you want to detect and it detects the right thing. I think the other thing is, again, a little bit what I talked about before is it's not, I don't think it's enough to have a model. There's a lot of different options out there, a lot of models out there. I think it's key to bring together an integrated solution. Customers sometimes want to bring their own model, or they need to tune a model for a different application. They work differently in different parts of the world or at different times of day, or for detecting or looking at different things or different patterns. And so you need to, I think, one, enable some flexibility around the model for that to be useful. And then also bolt around some of the things that make it difficult to use a model. Again, orchestrating the satellites, different constellations that see different things. If you need SAR to say look through clouds or look at night versus day, and then put those things together. That's a lot of the automated, the manual workflows you're talking about is a big impediment, I think, to using AI. And so if you put the AI with some of the workflows, they become an incredibly valuable product. And I think that's what we're just starting to see is integrating these things into a solution.
We've been investing in AI for probably 6 or 7 years since we really launched like the first stable version of our platform. And for us, AI was really about internal scalability. So we talked about the spatial accuracy problem. So for us, it was investing in machine learning that would take imagery, identify ground control points within that imagery, and then make sure we can automatically align it against the base map and then automatically recorrect the lat-long values. We've used AI in, we have what we call an image quality score for every image that goes through the platform. And so we look at, that's always indexing against previously poorly graded image quality scores. So whether that's for cloud, haziness, poor radiometric corrections, et cetera. And as new imagery is going through, we're creating these quality scores where if there's something poor, a person can get flagged about a poor image potentially going out to a customer. And then, for us, we've invested a lot in what we call tasking optimization, right? So we provide access to about 700 different sensors in orbit today across 20 plus different providers. So a request comes in, we're trying to figure out so if you need that image over that particular area next week, we're looking at, automatically what partners are going over that area of interest, what's the weather going to be like during those passes, what's the capture angle, what's the resolution, et cetera. So we're taking a lot of considerations, a lot of variables into consideration to ensure that we're passing on an image or an image collect opportunity to the right partner for capturing that image. And then additionally, as we think about now, how can AI enable users to mass adopt imagery? From my perspective, I look at it as a way to really take accessibility for ordering and utilization from the small geospatial team inside of that Fortune 500 to anybody inside the organization.
Is this the technician that Beau was talking about? Like you're kind of bypassing that, you no longer need the...
Bypassing it,
Yeah.
right. So like just, things that we all maybe take for granted now, even though we're only like 3 years into a ChatGPT world, but like just being able to use your natural language to order data, or at least to describe the problem that you're trying to solve, and then translating that into orders and optimizations that then ensure you get those collects and you get your use case fulfilled, right? And when you're able to do that, you're able to enable anybody, tens of thousands of people inside of a large enterprise to now order data, which creates new problems for finance and operations and whatnot, which is then where we sell more solutions.
Those are
to
good
kind
problems.
of tighten that up. But they're good problems to solve. They're good problems to have.
Yeah. Are we going to get to a queryable Earth? Like, is that a thing?
Oh yeah, we should.
Yeah?
We
Like a Google
definitely
search bar for the physical world?
Yeah, and text-based, natural language-based. Find me and deliver me the appropriate data for the fire that's currently happening, and the insights. Can I say one more thing about the
please.
AI? Because one of the things that I've noticed with AI, which has been, I think, great for our industry, is that AI is expanding the usability of sensors and modalities that go beyond the visible. Okay, so the visible being, electro-optical, a picture that you can see. A lot of the new modalities that are going to bring the best insights are not in the visible wavelength of light. Things like hyperspectral and SAR. And these are modalities that have been around for a very long time, but were very much in the realm of the technician again, but had unique job categories: spectral scientist, image scientists. Spectral scientists, there's probably 100 of them in the world. So it made launching a hyperspectral satellite difficult to actually monetize and make money off of, because you required these people with very sophisticated workflows. AI has the opportunity to bring the insights that these satellites or these sensors can give down to Earth, especially with SAR, and expand their use. SAR has tremendous potential because of its day-night all-weather, but it takes a trained analyst to interpret that data. AI is really good at it. So I think that it's really important that we're applying AI to some of these newer modalities so that they get funded, they get mass adoption. Because they combine with EO, that's the sensor fusion that's going to make the difference in solving problems.
Okay, so we have a proliferation of sensors in orbit and all over the place that we are now fusing and bringing all of that together into a platform like SkyWatch, which is making it accessible to a vast number of customer organizations and users. In our last few minutes, I'd really just like to touch on what are you most excited about in the future, like next-gen applications now that we're here and we're applying AI to all of this stuff. Like where do we go next?
I'll go quickly. So I'm most excited about users, the broad user base being able to access the data they need at their location that is applicable to solve their problem. And that there's a lot to that statement. There's the data delivery, data formats, business models that work, that can get the data in and affordable. But that's what I'm most excited because the pieces are in place.
So for me, think about anytime you open up a base map right now, maybe 10 years ago, your standard default was a map, like a very basic OpenStreetMap. Today, your basic default is probably the satellite view, at least it is for me. And 10 years from now, your default base map will be 3D, which is really cool, but introduces, I think, a ton of complexity in the data capture, processing, and updating. That is going to introduce lots of opportunities in LiDAR, point cloud collection, stereo imaging, processing, et cetera. And it's going to be quite a fascinating world that we build. But you will, in 10 years, look back at how base maps were primarily just 2D. And because you'll open it up and you'll live in a 3D environment by default within the next 10 years.
Yeah, there's so much to unpack there.
So much.
We'll do that over the networking lunch, I guess. Anything to add, Will?
Yeah, I think I said it before, but just really excited about the integrated solutions that we are now able to bring to market. I think a lot of it is due to where we are in terms of we've brought a bunch of capacity online, very high resolution satellites with our recent launches. We have our partnerships with some of the folks here to get that data out, and then these other solution providers that are out there doing AI and other things are enabling to get, to bring to market some of these integrated solutions that are closer to what the customer's really looking for, whether that's a navigational, GPS-denied navigational product or a site monitoring and intelligence awareness product. So I think that's where the real opportunity is.
So just like GPS started as a niche capability and is now ubiquitous in everything that we do, the same thing is happening for Earth observation and geospatial intelligence. It is becoming ubiquitous. It is powering the world's largest global industries. And these gentlemen up here representing these companies are at the forefront of that and bringing it to you. So I just want to say thank you very much for being here and your attention, and for the panelists for sharing your thoughts with us. Thanks very much, guys.